All right, so we're still doing matrices. We're going to look at determinants. Now, what the determinant is used for, oh, hang on. All right, before we really talk about what they're used for, they're used to solve systems and find areas and do some other things. But first we have to figure out what the heck what they are. How do we even find them? So every square matrix, it has to be a square matrix, has a real number called the determinant. The determinant of matrix A is denoted as, so you can put DET for determinants, then like an A in parentheses, or what looks like the absolute value of A, when A is the name of the matrix. Okay. So we're just going to do determinants of 2 by 2 and 3 by 3 square matrices. So if the determinant of a 2 by 2 is called a second order determinant because it's a 2 by 2. So this is your rule. So the determinant of A, so like absolute value basically, looks like absolute value, it's not really what it means. And we're going to go with a down and up type of thing like you're doing a crossword. And it's not quite as important, the order, when you do it with the 2 by 2, but if we're consistent, the 3 by 3 will make more sense. So if we do diagonals, so starting with the top left A, I'm going to make a diagonal down and have A times D. This is going to equal A times D. And then I'm going to subtract, and then I'm going to go from the bottom left, and I'm going to go up C times B. And that's going to give me a single number determinant. So that means when we do these diagonals, we're going to do down minus up. To remember that, you just think, duh, right? Duh, down minus up. That's what you do it. So I would remember it. Easy enough? So on this first one, we're going to actually write everything out just so that we can make sure that we understand what the heck is happening. And then maybe we can skip a few things. So I'm going to start here. I'm going to do my down diagonal. So I'm going to take a -4 and multiply it by a -10. Then I'm going to do an up diagonal. So it's going to be and I subtract it, minus +5 times +3. So -4 times -10 is 40, minus 15, and that gives me 25. And that's my determinant. Right now it just seems like a random arbitrary number you're getting, I know, but we've got to learn how to do it, and then we'll look at how we're going to apply it. What questions you got? So, do you have to show all those steps every time? No, you do not. So we could just do, if you're going to do this, and whether or not you circle them, that's up to you too, but -6 times -2 is 12, minus, and then this would give me minus a -33, so just be careful with your signs, and you get 45. Okay? What questions you got? And your determinant can be positive or negative. Right? So you go ahead and do 3 and 4. You can use your calculator to help you if you want so that we don't make up ridiculous mistakes. I will say this though. There is somebody taking college algebra at San Jac right now. Miss Tremont, I'm just trying to remember the full story now. Miss Tremont ran into them, so they were like, this is kicking my butt. They've also been out of school for a couple years, but either way. She said, do you get to use a calculator? And he was like, no calculators at all. It depends on the professor. He also said, and see, this is the thing about college. All right. I thought this was going to be easy. Apparently not. Oh, what the heck, man? I'm not going to be able to use it anyway. I guess I can use it once. I'm going to pick 2 people because I don't know if I can get back to this. Sandra. Oh. And Patrick James. All right, Sandra, what'd you get for number 3? -80. Do we agree with that? Yes? If we don't agree and I need to do it, let me know. Patrick James, what did you get? Is it -40? Is that what y'all got? Yes, that is correct. All right, any question about either one of those? That's very simple, right? Okay, so really the 3 by 3 is not necessarily more complicated. It's just kind of weird, I think. Here's a little disclaimer, is that your assignment is in Delta Math again, because I think that's probably, I'd like that Delta Math can help you with it, but on these 3 by 3s, Delta Math does it differently because there's two different ways to do it. And when I was looking at the way they were doing it, I was like, what? Like it's just weird. Like if you want to do it that way, go ahead. I wouldn't suggest it, but it's just a different way to do things. So here are steps, okay? Our step 1 for a 3x3. And I was also going to tell you at the beginning, I don't know, you see how these have little legs on the bottom? The little legs aren't on the top, and I don't know why. They are like on the computer, but they don't print that way, so they're supposed to be actual brackets, you know, that look like this. Like that's the actual bracket. Just so you know, like notation-wise, it's important. All right, so we rewrite the first 2 columns to the right of the matrix. So this is a 3x3, so we're going to take this column, whatever your first column is, we rewrite it right here, 3, -5, 1, and the second one, so the first 2, -7, 4, 5. So I'm not making up those numbers. Those numbers are just coming straight from the matrix, okay? And so then it says find the sum of the products of each of the downward diagonals. All right. So we start with our diagonals. Here's a down one. I start at the top left. There's one diagonal right there. Then there's another diagonal right here. And then there's another diagonal right there. You see those 3? So for the down, we have the first one is 3 times 4 times a -1. Okay, I'm multiplying these 3 numbers together. This gives me a -12. Everybody understand where the numbers are coming from? The second one, I do -7 times -5 times 1. Is that +35? And then 2 times a -5 times 5. So that's what? Let me write it out. 2. We're just going to write them out at least on this first one so we know where everything's coming from. And that's going to give me -50. All right, so then we add all those up. So it says find the sum of the products. These are the 3 products. I need the sum of the products. So that would be -27. Somebody check me. Don't ever trust my subtraction in my head. Okay, that's what my answer key says too, so I'm hoping I'm right. Everybody understand where that came from? Okay, so I basically took the top row and did a diagonal down. Now I got to go back and do the diagonals up. So I start with this 1. And I got this right here. So my up diagonals, my first one is 1 times 4 times 2, which is 8. And then this is my next one. And whether or not you circle them every time you ever do it, that's up to you. Just at least, make sure you've got them lined up right. And then this is 5 times -5 times 3. I'd say -75 there. And then this, -1 times -5 times -7. I'm going to go with -35. -102. All right, so we rewrote them. We found the sum of the products of each downward diagonal, then each upward diagonal, then we subtract them. So remember when we subtract, it's down minus up because duh. So you get -27 minus a -102. Your final answer is 82. So like I said, not difficult, but weird. Just different. Easy enough? We're good? What questions you got? All right. Flip it over. Let's do one more together. So I'm going to rewrite 6, -1, -3. 4, -6. Okay, so I know the chances of y'all actually writing all that stuff down is like slim to none. I mean, I'm not new here. So here's down. So if I'm going to multiply 6 times 4 times a negative 4, you do that on your calculator. The first column, you mean? Why do you use the first column instead of the first row? Is that what you're asking me? Oh, because we need a diagonal of 3. That's why we had to rewrite these over here so that we could actually extend that. See, this negative 3 gets used over here, and this 6 gets used over there. It just has to it kind of like wraps around almost like, but we can't really write it like that. That's a good question. So this gives me what? Negative 96 would be my first one. And then if I do negative 3 times 2 times negative 3, I have 18. I did these 3. And then that would give me 36. So negative 42. Y'all agree with that? If you want to do your little like circling like it's a crossword puzzle, not a crossword puzzle, you know what I mean, a word search, then you can. But when I do that up here, it's probably better with your pencil. Then I can't even read my numbers. I might just do the first one. So it's 24 times 3, 72. So this is my up. It's going to give me a negative 72, and then a negative 24. And especially when you write them out, make sure you know what's lining up. Negative 12, I believe. Plus 24 plus 72. Negative 108. Nope. Nope. Nope, nope. What did I do wrong? Oh, this isn't 24. That's negative 72 also. So 144. Yeah, negative 156. See, I don't think I was lining up the stuff right. And then we do down minus up. Get negative 42 minus a negative 156. And if you are able to use these calculators, then we all know how to use the negative sign correctly on here, right? Don't use the minus sign. It doesn't like that. You have to use the negative sign. All right, we agree with that? All right, then y'all do the 7 and 8 without me talking you through it. Then we'll apply one, and then I'll give you time to work. You're second guessing yourself or what? You're just staring. You don't trust yourself or what? That's right. See? Be confident. Be good. And just so you know, there's ways the calculators just do the matrices and stuff for you too, but it's one of those things where we got to know how to do it by hand. And maybe we need to know how to do it on the calculator, but I don't know where you're going with this. So. Yeah, you slacker. Where's your final answer here? This one? Oh, look. When you subtract a negative, though, it becomes plus a positive. Well, no, yeah, you're right. Oh, look, it's negative 148. You didn't write the number down. That's why. Yeah. I was like, no, that would make it right. That wasn't a mistake. All right, I'm going to pick my two peeps here. Maria and Sandra. All right, Maria, what did you get for number 7? Negative 38. Okay, y'all agree with that? Yep, down minus up. Very good. All right, Sandra, what did you get for number 8? Negative 162. Do we agree with that? Yes. Okay, good job. So fairly simple, right? A little weird, but, and we'll see, we'll look at also why it works and stuff like that after we learn how to do it. We got to learn how to do it. Then same with this here. So we're going to do this triangle one because this is a way to find the area of a triangle when you have ordered pairs. So computer programming uses this stuff too because, you know, when you are programming stuff, you're actually plotting things in different places. So this is one of the ways that that kind of stuff can be used. But, and why the ones are in here, this is what I was trying to figure out today. Because like I've known this formula, but I never really thought about why was it 1. I was just doing what my teacher told me to do. And it's one that I can explain it to you after we learn it. It has a lot to do with how the other way is to work it, but we'll look at all that. We're just going to do one. Just right now it's this because I said so. So the area is 1/2 base times height. Now one of the things that the determinant can give you is the area of the parallelogram that has those numbers related to it. And so parallelogram is just base times height. That's why this is 1/2 the determinant because it's basically 1/2 base times height. That's all that's happening there. So here are 3 vertices, okay? And here's what it says, we don't have a name for it. So just, okay, our determinant is going to equal. And we're going to put in these, it's xy, 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 right? So I'm going to have a -5, -2, no parentheses or anything, so no commas. And then 3, 9, and then 7, -4. And then the third column is just all 1s. Again, right now, because I said so, we'll look into it a little bit more about the why. Then what I need to do, the area is equal to 1/2 of the absolute value of the determinant, because notice our determinants were able to be negative, but your area is never going to be negative, so it's actually the absolute value of the determinant. So then I need to find the determinant, which means this is a 3 by 3, so I have to add the column out here. Remember, you do not have to do this for a 2 by 2. Okay. So go ahead and figure out what the determinant is. Let you type through that again. So we're going to get 1/2 times the absolute value of, figure out what that determinant is. Okay. Your signs are wrong. You have negative, negative, negative for the all three of the downs are negative, 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 and your ups are positive, positive, negative. Because I think your second up is the one that's, because you'd have 4 times 1 times a negative 5. Right? 4 times 1, like that's your, this is your first one, that's your second one. So you have negative and negative and positive. I don't know. What do we get for the determinant? Negative 70 what? Okay. 1 or 4? What'd y'all get for the determinant? Oh, I'm sorry. I'm a moron. You're right. It is 148. The final answer. I was looking at the final answer, but like she got 71 and 74 is what I had written down. It was so close. Oh, negative 148. Yeah, okay. The determinant. I'm sorry. Let me ask it again. Let me be ready for the answer. Negative 148. And so then we take half of it. It is positive 74 is the area. No, that's okay. I know. My question wasn't clear, and then you threw me off when it was so close to 74, and that's not even when I wasn't even asking for the 74 number. We good? Now I want you to think about this. If we just have 3 ordered pairs to give us our vertices here, if I wanted to find the area of this triangle, and I'm going to use 1/2 base times height, like I need to know the distance. I'm going to have to use distance formula for this. And I would have to find the center, or I'd have to find this perpendicular here and find this. Like, that'd be a lot of stuff to do, where as weird as this is, it works, and it's a whole lot easier to do, right? And again, I'll show you why it really works after we've gotten this down. And then we're not going to do it again, but it's the same type of thing. Like, here's 3 cities. Here are their coordinates. If we put it in here, find the area of land that's between them or whatever. All right, any questions at all? We good? If you didn't get that negative 148, did you find where you went wrong? Because, I mean, it's so easy, isn't it? It's easy to mess up a sign somewhere. It really is, so just be careful.